Hey again, and welcome back. Something a little different today, but not entirely off base for this channel. I want to take that 555 timer PWM circuit, which I've showed you in previous videos, and make it into a circuit board, which then we will send off to some Chinese manufacturer, I'm sure, maybe some local ones. I don't know, we'll see. And then make it into a real thing that I can solder together. And I am planning on sending a few people this board, and some of those will be my Patreon patrons if they want one, and hopefully to some of you guys, the watchers, too. But basically my YouTube friends and my Patreons will get first crack, and I might have to either raffle off or find out some sort of giveaway for the rest of my viewers. So the software we're going to be using today is KiCAD, and as you can see up here, I already have done this, and I've done this for a specific reason, is because I don't want to lead you astray. So one, I am not an expert at this. If I can do it, so can you. And two, I will show you my way of doing this. As I get more familiar with the software, that might change, but for now, this is what we got. So I'm going to start a new project here. So I already have a folder called 555 PWM. I will make a new folder called 555 PWM2, and we will save it in here like that. So now we have, this is what you get in KiCAD. This is not the latest version of KiCAD. I think it's only one version behind, though. I didn't want to change what I already had. So we're going to start. The first thing you need to do is you need to make a schematic. So basically, I think it is this one here. Yes. So you have your schematic. Here we go. So it's right click, you get the special options, left click, you get to highlight, and middle click and hold, you get to drag things around. Then mouse wheel in and out is your zoom. So the very first thing that I did, I'm not sure if it's what's supposed to be done, but the very first thing is you want to set out your components. So I'll put the schematic I'm working from, the one I drew, I'll put it in the lower right of the screen here and show you the stuff that we need. So here we've got place symbol. So I'm just going to left click. It has to load the libraries, which is fine. Now I have not added any libraries to this. I know that there are libraries you can add, but nothing. This one is just out of the box KiCAD. So I'm going to search here for 555, and I think they are NE 555 timers that we have. So I'm going to put that there and plop it onto there. We need 2 diodes. So let's again left click because we're already selected on our so diode, that looks like just a standard diode. That's nice. Diode for symbol. Let me just stretch this out a little bit. Okay, pin order incompatible with official KiCAD footprint, so let's not do that. Here, device, diode. Yeah, we'll grab this guy. And then there's the filled shape. I don't know which one I like best, so I'll just put this one here. Okay, now I'm going to highlight this, Control copy, Control V. Now we've got 2 diodes, because we need 2. Now I need a potentiometer. So again, I'm going to click, oops, place, click, potentiometer. This is digital, we don't need digital. Device, our pot, this dual pot. So let's just go regular potentiometer, just a variable resistor. There used to be a different, our variable, nope, our variable US. Oh, here we go. The US style potentiometer, or the kind of generic style. I like the US one. That's the one I use with my students, so that goes well. Put that in there. I'm going to zoom in a little bit here. Alright, So we've got the pot, got 2 diodes. We need 2 capacitors. Now they're non-polarized, but I think I want to put an extra one. So capacitor, simulation only, sensor touch, device, polarized, unpolarized. Okay, put one there. Now we can grab another one, put it right next to it. Okay, and I think I'm going to add actually a third unpolarized, just from what I learned from my previous attempt. And I'm going to put one polarized. Power management, sensor touch device, polarized. There we go. So we've got that. So we've got the, we need one resistor. So over here, and there's many ways to do this, by the way. I just, this is the way I'm doing it. I just need a regular resistor, small. There's just a regular, yeah, resistor US symbol. I like this squiggly better. So there we go. We got one resistor. We need a 12 volt source. So I don't remember if this is, there we go, plus 12. We'll grab that, put that over here, and we need a ground. Yeah, I like the other symbol, this one, I guess a reference ground. I don't know the difference, but there we go. And now I want to add one more component. Is you need a kind of a way to connect to this. And again, I only know this because I have practice. And I want a terminal block. So screw terminal, there we go. Generic connector. I don't know which one is typically positive and which one is negative, but there we go. So we have all our components. You can now label them. So I believe it is, oops, I'm still placing. Grab this click here. Yeah, so double click. So that'll be RV1, that's the thing, and the value will be 50K, because it's a 50K ohm pot. Okay, so RV1, 50K. Grab this guy. This will be R1, and this R1 is 1K. There we go. Now we have 3 capacitors. I want a 0.1. I need a 0.1 microfarad. So let's go C1 value 0.1 UF, like that. And we actually need 2 of these, but I will do the polarized next. C2, and that will be 470 UF. Now I just added these because I think they'll make it more stable. And oops, I keep doing that with my mouse wheel. Not all software has the same. Yeah, this one. I want to double click that. Not all software uses the same hotkeys. 0.1 UF. So when you switch between, like, say, my editing software and my when I move between the editing software and like KiCAD, for example, I get a little confused. Okay, and this will be C4, which is 0.01 UF. Whoops, that's backwards. UF. Darn it, did it again. Okay. So we've got that, we've got that. The diode doesn't really matter, but I'll just put D1, and this will be like, is it 2N4001? I think that's what the value is, but I'll just ignore it. Yeah, that's fine. Empty, okay. And here will be D2. Oops, D2. that. Okay. This 555 will be U1, the first one we'll get. The jumper or the terminal block will be J1, and then we don't need to show its value. Okay, so this is the first step done. This is just all the symbols we're going to need, and they're all just kind of splayed out. Next thing you want to do is start to sort of make your circuit look cohesive. So I'm going to take all of these components and kind of move them to the side, like that and like that. And now if you see here, our 555 timer VCC is towards the top, ground is towards the bottom. So the logical place to put our 12 volts is up top, and the logical place to put our ground is on the bottom. So that's done. Next, I know for a fact that I want my jumper here, like this, to be connected between 12 volts and ground, right? It makes sense that if 12 volts comes in on the jumper and out, the ground comes from the jumper, we want one to be connected to 12 volts, one to be connected to ground. So I'm not sure if standard by definition number 1 or 2 should be 12 volts or ground, but I don't know. This might be just convention, so I'm not sure. I do know my filter cap here, this guy, will have to be in between power and ground as well. So it'll come here, and my large reserve capacitor kinda will be over here as well. So you know the connections will be simple to go from power and ground. My pot, I like the way it's oriented in my little schematic, so I am going to put it sort of over here and facing like that. And I know the diodes will be nearby because they connect to them, and I know that they'll be oriented in opposite ways. So you can see already we haven't done too much, but you can see we sort of have a general understanding of how the circuit will be laid out, and we can sort of massage it around to how we like it later on. But you know, we can start connecting things. So definitely we know that we want power to come in, and this is a place wire here, the tool in the corner. So we definitely want power to come in here. Boom, this is done. And ground to come in here. If you're an expert at KiCAD, then I'm not sure what you're doing watching this, but this may not be the best way to do it. This is just a way to do it. We know the 12 volts will connect down to here. We know the ground will connect down to here. Now we know these capacitors also have to be connected, so I'm going to connect that up here. Connect that up here. Connect this here. And connect this here. There we go. Pretty simple so far. We haven't done anything magical yet. We also know that our resistor here will connect to our diodes. I'm actually going to move the resistor down one. I think that will sort of line it up. And then we're going to take our wires, go from here to here, and then from here to here. There we go. And we know our diodes need to connect to the potentiometer. Here. Oh, actually, I think I made a mistake here. So I'm going to press escape there, grab the potentiometer, and rotate it. Rotate is R key. Okay, I'm going to grab this. Should be able to grab it. There we go. Move it up. It's actually, I can tuck it way in there. There we go. And use my wiring. Grab the wire, connect to here, grab the wire, connect to here. Everything is fitting so far. Okay, we also know that we need pin 2 to connect to pin 6. Now on the circuit board you can do this kind of through the actual IC, but I don't think that's possible here. So we're just going to move it sort of over, down here, across here, up here, and to there. So 2 does connect to 6. And this is only for schematic sake. This is not, you can tell there's not connected there. It's a little bit confusing, but it's not too bad. We will figure it out. We know 5 needs to connect down to ground, but through a 0.01 microfarad capacitor. So we're going to grab this 0.01 microfarad capacitor. I'm going to stick it right there. And then grab my wire, and then 5 will come out like this, here, connect to this guy, and from this guy, connect to this guy. And there we go. 4 is reset, and that will be tied high, so I'm going to take it out here, bring it up here, like that. And 6 is a little bit more complicated, but not that much. So I grab 6. It has to connect to the wiper of the pot, and then from 6 it needs to tie through a capacitor, this one here, C3, to ground. So it's actually a little bit tight, but I think we can make it work. Connect this guy to this guy with a wire, this guy down to here, I think this is level, to here with a wire. And then R1 needs to come up to 12 volts. I think it's here. Yeah, it's here. There we go. 7 needs to connect over to these diodes here. So I'm just going to make that kind of clear by going up and then clicking there. There we go. Now our diagram is done. Number 3 actually goes off to, this is our output. So we could put a MOSFET or something in here, but I don't think that'll be the point of this. I may add it actually. You know what? Let's add it. So let's go up here. I'm gonna add a MOSFET, not a driver. I don't think power management. Relay, transistor FET. Device. Should be just in device. You know what? I'm just going to pause here. I'm going to check to see if my specific MOSFETs are listed, and then I will bring you back. So I just checked, and my MOSFET is a FQP 30, and no, it doesn't look like it's in here. So I might just try to get a regular MOSFET here. So I'm guessing it's just going to be in device. Let's see. Should just be generic. I don't see. Let's see. This way. Zener. I'm not sure which. I think it is gate drain source. Gate drain source. We can always yeah, we can always fix this after. It's not that big of a deal. So we'll grab it here, put it over here, and now we can put our wire to come across. This is our output here, like this, like this, like this, like that, and this guy, I think I've got it backwards actually. Gate source drain. I feel like that MOSFET is backwards, or that that diode in there is backwards. No, actually I think it's fine. We'll soon find out anyways. So this needs to go directly to ground here like that. And then this guy will have to go up to a screw terminal. So let's put another terminal in here. Oops, this guy here. I'm going to grab a screw terminal here. Like this. Edit the properties of this guy. This is be Q1. And this one will be J2. Eliminate this. Actually, I'm gonna eliminate this as well. Don't need to see it. And so our device is going to take power directly from this board, because why not? Like that. And then it's going to return into the MOSFET and the MOSFET to ground. This might be upside down, this MOSFET. If it is, I will fix it in the next video. And I almost forgot one important part. I usually want to bias the gate one way or another, so pull up or pull down. And on this one I think I want to pull down, therefore connect the gate to ground by a fairly high value resistor. So we're going to add one more thing to this. We're going to grab the resistor and we're going to pop it into here. I think I'll put it in line like this. Edit this to say R2. Oops, not the text. This. Edit this to say R2, and we'll make it a fairly large value, maybe 10K. There we go, and we connect it with a wire like this. And I think this is our final layout. This is what it's gonna look like in our schematic. I'm trying to do a real quick check, and I don't see anything wrong with the circuit. Now we may find things wrong, but that's kind of part of the process. And so the next step will be getting ready for this to go onto a PCB. If you want to see that, make sure you tune in to the next video. Thanks again guys for watching, and I'll see you next time.